Our universe is filled with countless planets, each unique in its own way. While many planets share common characteristics, some stand out as truly one-of-a-kind worlds. In our vast cosmos, there exist planets of diamond, lava, and ice, planets where it rains glass sideways. Planets so close to their stars they're tidally locked, and planets so massive they defy imagination. In this article, we will explore some of the most unusual, extreme, and downright strange planets detected so far in our inconceivably big universe. The Blue Planet, where it rains glass. Located 63 light-years away in the constellation Vulpecula, planet HD 189,733 Bits is one of the most exotic exoplanets discovered so far. This gas giant is tidally locked to its star, meaning the same side perpetually faces the star. Surface temperatures on the day side reach 1,700 degrees Fahrenheit, hot enough to melt metal. However, it's not the scorching heat that makes this world so bizarre, it's the precipitation. Recent observations indicate that on HD 189,733 Bits, it literally rains glass. The immensely high temperatures coupled with ferocious winds reaching 5,400 miles per hour are thought to turn silicate particles in the atmosphere into tiny glass droplets. Researchers believe it rains silicon dioxide glass sideways on this turbulent alien world. Additionally, the strong winds carry the evaporated glass to the cooler night side, where the glass condenses into glittering crystals. The blue color of the planet comes from the hazy silicate particles in the atmosphere's scattered blue light. With its hellish environment of raging glass storms, HD 189,733 Bits is undeniably one of the most violent and unusual exoplanets found. TRAPPIST 2 Bits, the darkest planet ever discovered. Orbiting the star GSC 03549 to 02811, located 750 light-years away, TRAPPIST 2 Bits is the darkest planet ever discovered. This gas giant closely orbits its star and has a temperature of 1,800 degrees Fahrenheit. However, instead of reflecting light like other hot Jupiters, TRAPPIST 2 Bits absorbs over 99% of visible light due to the presence of gaseous sodium and potassium that trap light in the atmosphere. Consequently, TRAPPIST 2 Bits appears profoundly black, darker than charcoal. The planet is so dark that it's literally darker than paint, coal, and even the night sky. In fact, TRAPPIST 2 Bits reflects less light than a black acrylic paint made by NASA called Black 2.0 that absorbs up to 99.9% of visible light. Researchers were astonished when they found this asphalt world using NASA's Spitzer Space Telescope in 2019. With its unprecedented blackness resulting from novel atmospheric chemistry, TRAPPIST 2 Bits remains one of the most mystifying worlds discovered. GJ 1214b, a steam world enshrouded in thick fog. GJ 1214b is a steamy water world enshrouded in a thick blanket of humid fog. This super-Earth exoplanet orbits the red dwarf star GJ 1214 40 light-years from our solar system. It's called a steam world because computer models indicate the intense heat from its nearby star likely turned its surface water into vapor, enshrouding the planet in a dense, foggy atmosphere. Observations show the atmosphere is dominated by steam, with a high prevalence of hydrogen atoms. The thick steam traps the planet's heat, resulting in an average temperature of 230 degrees Fahrenheit, hot enough to boil water. While we can't see the surface directly due to the opaque fog cover, astronomers believe GJ 1214b may harbor deep oceans of liquid water underneath its vapor atmosphere. This unusual steam-covered planet demonstrates that worlds radically different from Earth can still potentially be habitable. The discovery of GJ 1214 expanded our understanding of where else life may reside in the universe. CORT 7 Bits, a planet made of lava and rock. Deemed the lava ocean planet, CORT 7 Bits is one of the most extreme exoplanets ever found. Orbiting its star every 20 hours at a distance of only 1.6 million miles, surface temperatures reach a scorching 3,600 degrees Fahrenheit. This heat causes the rocky surface to melt into a rolling ocean of lava. Researchers analyzing the lava planet determined its density matches that of Earth's continental crust, enriched in silicates like granite. Therefore, astronomers believe COROT7 bits is likely composed of the same raw materials as the rocks underlying Earth's continents. However, the intense heat from its star has melted the entire planetary surface into a roiling lava sea. This hostile world has no atmosphere and is tidally locked, with permanent day and night sides. COROT7 bits expands our knowledge of the diverse planetary landscapes possible. A magma world once thought only to exist in science fiction, COROT7 bits proves lava planets are a reality in our universe. Kepler 70 bits and 70c, the chaotic dance of a doomed planet pair. Kepler 70 bits and 70c form a planet pair destined for doom. Located approximately 5,400 light-years away, these gas giants unusually orbit extremely close together, at a distance of only 5 million miles. To compare, Earth and the Moon orbit at nearly 300,000 miles apart. Kepler 70 bits and 70c complete an orbit around their star in just 8 and 21 hours respectively. The planet's close proximity and highly elliptical orbits result in profound gravitational interactions. The gravitational tugging has tilted and expanded their orbital planes, bringing the pair repeatedly to the brink of collision. However, while Kepler 70 bits and 70 pass dangerously close at times, their orbital resonance has kept them stable for now. But astronomer calculations indicate this chaotic dance between the planets has shortened Kepler 70 bits' life expectancy. Within the next 10 million years, Kepler 70 bits is expected to plunge into its stellar host. The impending catastrophe makes Kepler 70 bits and 70 one of the most dynamically fascinating and unusual exoplanet systems discovered. HD 10180 system, a planetary system rich with exoplanets. Located 127 light-years away, the HD 10180 system hosts an extraordinary number of exoplanets, making it unprecedented among planetary systems discovered. The central star HD 10180 is an ordinary Sun-like star. However, astronomers were astonished when analysis uncovered evidence indicating the presence of at least 9 planets orbiting the star. This makes HD 10180 the largest exoplanet system outside our own solar system. The detected worlds are relatively small, with estimated masses between 12 to 25 times that of Earth. While our solar system hosts 8 planets, most other systems discovered only contain 1 or 2 planets on average. The rich diversity seen in HD 10180 suggests planetary systems saturated with many planets may be more common than once thought. While the architecture of HD 10180 is strikingly different from our own solar system, its sheer number of exoplanets demonstrates the vast arrangements possible in planetary systems. For this reason, HD 10180 stands out as highly unusual and remarkable. 55 Cancri, a diamond world of scintillating beauty. 55 Cancri is a planet made of diamonds. Located 40 light-years away, this super-dense world orbits extremely close to its star, completing one revolution every 18 hours. With surface temperatures around 4,900 degrees Fahrenheit, scientists theorize the immense heat and pressure have transformed the planet's carbon-rich interior into diamond. Theorized to be 1/3 carbon by mass, the interior likely resembles a giant diamond, with layers surrounding a solid core. Interestingly, the high temperatures would make these diamonds glisten in all colors of the rainbow like a disco ball instead of clear like diamonds on Earth. Moving at super-fast speeds of 1 million f, strong winds likely cause the diamonds to rain downwards constantly. The diamond rains accumulate on the cooler night side into glittering mountains. The idea of a planet rich in diamonds captivates imaginations. But more than that, 55 Cancri expands our perceptions of just how bizarre and unexpected planets across the cosmos can be. The universe contains wonders that go beyond our wildest dreams. PSRB 1257 plus 12, a planetary system with asteroid and moon-sized worlds. Discovered in 1992, PSRB 1257 plus 12 was the very first planetary system found outside our solar system. This system amazingly consists of several asteroid and moon-sized planets orbiting a pulsar, the super-dense remnant of a massive star after a supernova explosion. Located 2,300 light-years away, PSRB 1257 plus 12 contains 3 confirmed planets, unofficially dubbed Poltergeist, Draugr, and Phobiter by their discoverers. These tiny worlds have diameters of only 2, 1, and 4 times that of our moon respectively. Even more astounding, these planets spin around their pulsar in amazingly compact orbits, closer than the Sun's distance from Mercury. Their tight orbits take under a day to complete. The discovery of asteroid-sized planets was a revelation, proving planetary systems can arise even in the aftermath of a supernova. PSRB 1257 plus 12 forever changed our fundamental perceptions of where planets can exist and what they can be like. SWIPIS 11 and SWIPIS 04, the rapidly spinning planets. SWIPIS 11 and SWIPIS 04 are 2 bizarre exoplanets that spin at breakneck speeds of over 1 million f. Located approximately 4,000 to 120,000 light-years away, these gas giants orbit extremely close to their parent stars, completing each revolution in just 10 and 3 hours respectively. At these close proximities, they experience enormous tidal forces from their stars that have accelerated their rotations to incredible speeds. In contrast, planets in our solar system take hours to complete one rotation. But SWIPIS 11 and SWIPIS 04 are spinning so rapidly they're nearing rotational breakup. This is where centrifugal forces equal the gravity holding the planet together. For comparison, if SWIPIS 04 was replaced with Earth, the rapid spin would fling people on the equator into space at 1700 f. The remarkable speeds of SWIPIS 11 and SWIPIS 04 provide insights into the powerful dynamics between exoplanets and their stars. Kepler-16b, a planet with 2 suns. Kepler-16b has the distinction of being the first confirmed circumbinary planet, orbiting 2 stars instead of 1. Located 200 light-years away in the constellation Cygnus, it circles 2 parent stars dubbed Kepler-16a and 16b once every 229 days. The stars themselves orbit each other closely every 41 days. Standing on the surface of Kepler-16b, an observer would see a pair of suns rise and set, with each star appearing 40x larger in the sky than our moon. At certain seasons, there would be a double sunset as both stars set together. The discovery of Kepler-16b demonstrated that planets can form and remain stable with 2 central stars, an outcome once believed improbable. Prior to this, circumbinary planets were largely theoretical. The existence of Kepler-16b opened our eyes to the wonderful diversity of exoplanetary environments, different from our own single-star solar system. PSRG 1719 1438b, a planet made of diamonds orbiting a dead star. PSRG 1719 1438b orbits the dense corpse of a star, and it's a giant diamond. This exoplanet amazingly orbits a pulsar, the remains of a dead star after a supernova explosion. The planet has an ultra-short 90-minute orbit, placing it insanely close to its host pulsar. Scientists believe the planet originally formed much further away as a normal hydrogen and helium gas giant. However, as the star exploded and contracted, PSRG 1719 1438b was dragged inward towards its current position. The immense density of the pulsar exerted enormous tidal forces that compressed the planet, stripping away almost the entire hydrogen and helium atmosphere. This revealed the carbon core, crushing it into solid diamond. With a density nearly 23 million times that of water, PSRG 1719 1438 is therefore likely one gigantic diamond 5,000 kilometers in diameter and weighing 10 billion trillion pounds. This bizarre shrunken remnant of a planet demonstrates the strange destinations planets can reach through stellar evolution. Trace 4-Bits, the darkest planet ever found. Trace 4-Bits is the darkest alien world ever discovered. This hot Jupiter reflects less than 1% of any light that hits it. Orbiting its parent star every 3 days, surface temperatures reach 1,700 degrees Celsius, hot enough to vaporize metals. This heat excites potassium and sodium atoms in the atmosphere, making the planet profoundly dark at visible wavelengths as the atoms absorb photons. Remarkably, Trace 4-Bits reflects less light even than black acrylic paints designed by NASA to be ultra-black. The darkness is so intense that if Trace 4-Bits had a moon, the moon would be brighter than the planet itself. Trace 4-Bits demonstrates that exoplanets can be physically very different than those in our own solar system. The discovery of such an extremely dark world adds to the diversity and complexity of planetary systems known to exist. Gliese 436-Bits, a planet of ice and fire. Gliese 436-Bits is a Neptune-sized oddball that defies classification. Nicknamed the Hot Neptune, it orbits 30 times closer to its star than Mercury does to our Sun. Temperatures reach 439 degrees Celsius, hot enough to melt lead. However, the intense heat has not stripped away the planet's atmosphere as expected. Astronomers discovered Gliese 436-Bits has an envelope of hydrogen, helium, and water vapor surrounding an icy core. Models indicate the core is made of higher pressure forms of ice like hot ice, superionic ice, and even ice VNI at thousands of degrees Celsius. The strange ice within an atmosphere hotter than Mercury's perplexed astronomers. Gliese 436-Bits crosses the traditional boundaries between a rocky super-Earth and gaseous mini-Neptune. The perplexing planet illustrates how exoplanets can radically differ from those in our solar system. Kepler-10c, the mega-Earth. Kepler-10c has stunned astronomers with its immense size, dubbed a mega-Earth. This exoplanet is an extremely dense rocky world with 17 times the mass of Earth, making it the largest rocky planet known. This places Kepler-10c between Earth and Neptune in size. However, its mass implies a dense, solid surface, likely composed of silicates and iron, lacking a thick gaseous envelope like Neptune. Kepler-10 orbits its star once every 45 days in the constellation Draco, 560 light-years away. Models indicate a day on Kepler-10 lasts just 23 hours due to its high density and rapid rotation. The discovery of Kepler-10 was astonishing because planets this massive were expected to gather large atmospheres of hydrogen and helium, becoming gas giants like Jupiter. But Kepler-10 upends traditional planet formation theories with its improbable size and dense rocky nature. This extremely unusual mega-Earth illustrates how exoplanets can wildly defy expectations. N-Serpentis, the incredible shrinking planet. N-Serpentis showcases the death throes of a planet being cannibalized by its aging star. Located 1,500 light-years away, N-Serpentis is a white dwarf star slowly consuming Jupiter-like exoplanet N-Serpentis b. The dying star shreds off material from the planet that forms a spiraling disk swirling inward. The disk heats up, emitting huge amounts of X-rays and ultraviolet radiation. Over 18 years of observation, astronomers measured the orbital period of N-Serpentis be decreasing by 2 minutes per year as the planet moves closer to its stellar grave. Current models indicate the planet will be completely assimilated in around 1 million years. N-Serpentis offers a rare glimpse into the future of our own solar system. In 5 billion years, our Sun will enter its red giant phase and likely engulf Mercury and Venus. Witnessing the consumption of N-Serpentis, it provides insights into the demise awaiting planets in our cosmological backyard. HD 209,458-Bits, a planet with comet-like tail. HD 209,458-Bits has the exotic distinction of being a planet with a tail. This hot Jupiter orbits precariously close to its star, heated to temperatures above 1,000 degrees Celsius. Powerful stellar winds strip atoms from the planet's upper atmosphere, forming a gaseous comet-like tail tens of thousands of miles long trailing the planet. Observations of HD 209,458 bits as it transits its star revealed the tail by the absorption of starlight passing through it. Astonishingly, the tail exhibits transitory changes in density and direction on timescales of just a few hours due to interactions with the stellar magnetic field. The unexpected cometary tail streaming from HD 209,458 bits demonstrates exoplanets can experience intense atmospheric stripping and exhibit dynamic processes completely unlike anything seen in our solar system. WASP 12 bits, a planet disintegrating before our eyes. A planet on death row, WASP 12 bits is being torn apart by its star and spiraling towards oblivion. This hot Jupiter orbits its star in just 26 hours, an insanely tight 1.1 million km orbit. The extreme proximity subjects WASP 12 bits to enormous tidal forces from its star that distort the planet into an egg-like shape and heat its upper atmosphere to 2,600 degrees Celsius. The resulting thermal expansion generates gaseous magnesium and iron trails, tens of thousands of miles long, streaming from the planet. Don't forget to like and subscribe to our channel so you don't miss new videos.